Hi guys, I am Muchekwa Aaron Tangeni with Maths XYZ, and today I will be taking you through effective and nominal interest rate and also another example on missed questions on compound decay and growth. Alright, remember with the effective interest rate, the equation that we used is I effective is equals to open brackets 1 plus I nominal divided by m close brackets to the square root of m minus 1, which is written like this. It's I effective is equals to 1 plus I nominal divided by m to the exponent of m minus 1, of which in this equation I effective stand for effective interest rate and I nominal stand for nominal interest rate, and the m stand for the number of times on which the compounding take place in a year. Then another thing that you must also understand is that the nominal interest rate is what you actually get when you are being quoted at the bank or when you are making an investment, and the effective interest rate is the interest rate that you receive after the compounding has taken place. Alright, so in this question here we have TK who has invested 8,500 into a saving account and is quoted a nominal rate of 12.29% per annum compounded monthly. So the first question says determine the effective annual interest rate. So in this case, in this question here, even if they didn't say that it was the nominal rate, we must always know that if it's the one that is being quoted from the bank, then it's always a nominal interest rate. Then here what we need to calculate is the effective annual interest rate. So we have everything that we need because we have the nominal interest rate which is 2.29%, and the m is the number of times that it has been compounded in a year, which is 12 times because it's monthly, and the mm so as well it's also the same as this one, which is 12 and then minus 1. Then we have 1 plus is 12.29%, which is the nominal interest rate which has been quoted from the bank or from whichever account. Then m is the number of times that it has been compounded in a year. Then that's also 12 minus 1. That's it. So we just punch this into a calculator and found out how many percent is the effective interest rate. And also remember that the effective interest rate is always higher than the nominal interest rate all the time. So you can always tell if you're making a mistake. If you find the effective interest rate being lower, then you will know that it's actually wrong. So the effective interest rate that I got here is 13.01%. You see, then we can actually just agree that is the right one because it's higher than 12.29% of the nominal interest rate. So moving on to the second question, it says use the effective rate to calculate the effective interest rate to calculate the value of TK's investment after 4 years. So this time here we have to use the compound growth equation because the investment will be increasing. So it's A is equals to P into 1 plus I to the exponent of n. And so in this case we are also given the condition that we must not use the nominal interest rate but the effective interest rate which we have calculated from question 1, which is 13.01%. So here our P, we know that it's 8,500 because this is the initial investment that TK has made. So into 1 plus our I is the effective interest rate, which is 13.01%. So that's the one. And then our I, because it has been compounded monthly, then we must divide by 12. And then we divide that by 12 because our interest rate will be compounded monthly. And also with the N, we have it's 4 years. But those 4 years are the investment will be compounded each and every month. That means that we must also multiply by 12 so that it gives us the right answer. So just punch that into a calculator. It will be 8,500 into 1 plus 13.01% divided by 12 to the exponent of 4 multiplied by 12, which will give 14,262.95 cents. So after 4 years, after making an investment of 8,500, TK will have 14,262 in his account after 4 years, which let's just check how much he would have made from that, which he would have made 5,762 from the original investment. Alright guys, I hope you understood how to the difference between the nominal and also the effective interest rate, and also how to change the nominal into the effective interest rate using this equation right here. Alright, going to the second question. Sorry guys, let's actually put behind. Alright, with the second question here, it says that 16,725 is deposited into a savings account at interest rate of 11.25% per annum compounded monthly for the first 2.5 years, and 12% per annum compounded quarterly thereafter. After 51 months, 5,700 was withdrawn from the account. How much will be in the account after 7 years? Remember, with this type of question, I told you guys that you must always draw a timeline to know when and where did the deposit or an additional deposit take place, or when did the withdrawal take place. That will help you also to have in mind about the time changes, of which we're talking about 7 years here, and then this 51 months. The first one, it was compounded monthly, and the second one, it was compounded quarterly. That will help you not to make a mistake when you are dealing with this type of question. Alright, I'll just do a rough sketch of our timeline, of which we have 7 years. So this is our T0 right there, and we have 7 years in here. Alright, with 7 years, it says that 16,000, of which 16,000 will be in year 0. 16,000 is deposited into a savings account at interest rate of 11.25%. So here we have 11.25%, which is compounded monthly. So I will just write M for the first 2.5 years. So that will be T2. 2.5 years, 2.5 years. So it's the first 2.5 years, of which 16,000 will be compounded monthly at 11.25%, and 12% per annum compounded quarterly thereafter. Alright, so after the 2.5 years going forward there, now the interest rate would have changed to be 12% per annum compounded quarterly. So I'll just write Q. So that is from 2.5 to 7 years, of which that means that the compounding for the 12% it would have happened for, let's check, for 4.5 years. 4.5 years. Alright, because the first 2.5 years is 11.25, and the remaining time, which is 4.5 years, it will be compounded 12% quarterly. And then after 51 months, 5,700 was withdrawn from the account. Alright, then let's check how many months does 7 years have. 7 years has about 84 months. 7 years is about 84 months. So to subtract 51 months, that means that it was at it is left with 33, and then let's see how many years will that be. So it's when we are only left with 2.75 from 7 years then. So here we will say 7 minus 2.75, which will be 4.25 years here. Alright, then but when we do the calculation, we will consider the 51 months to be to have the interest rate to have the interest rate of only 2.7 years, because it will only be withdrawn at the year of 4.25 years from the first term. Alright guys, you know that when the interest rate changes, then we only just multiply. But then if there are additional withdrawal, or when there are additional deposit or withdrawal from the account, then we also have to subtract the P, which is the principal, or we can actually assume in that case that it will be a withdrawal or a deposit. Alright, so the equation doesn't change. It's A is equals to P into 1 plus I to the exponent of N. But then in this case, now that there was a withdrawal, then we will have to subtract the very same equation when we move forward. Alright, here we have 16,000, which is the original 16,275 into 1 plus, remember the first 2.5 years it was compounded at 11.25%. So it will be 11.25% divided by, it was compounded monthly, that means I will divide by 12 to the exponent of, it was only 2.5 years, so that will be 2.5 years multiplied by 12 there. All right, then this I will add that the interest rate changes, but then when the interest rate changes, if it's only that, then we just multiply out there. So I will add multiply with this one again. That means I will have to add into my equation here, which is n again there. So that will be 1 plus the interest rate changed to 12%. So that will be 12% divided by, it was quarterly, that means that I have to divide by 4. And to the exponent of, it was only for 4.5 years. So it was 4.5 years multiplied by 4. Alright, then again we have a withdrawal. That means that I have to subtract, and to my equation, that means I will have to add, subtract, 1 plus I to the exponent of n, of which our P in that case, it stands for withdrawal. Then the withdrawal which was made is 5,700, and the interest rate is still the same because the withdrawal happened within the 4.5 years after, when we are dealing with 12% compounded quarterly. Then that means here we have 12%, and then that means I will divide by 4 because it's compounded quarterly, and I will multiply with only 2.75. Reason why we multiply with 2.75 is because we want to take out the withdrawal together with its interest, because the 16,275 we have taken it through from year 0 up to the last year, which is year 7. But then we know that after 51 months there was 5,700 which was taken from the account. Then that's why we have to subtract the withdrawal together with its interest. Alright, then here we have 16,275 into 1 plus 11.25% divided by 12 to the exponent of 2.5 multiplied by 12. That will be multiplier. We have to multiply again with 1 plus 12%. Sorry guys, 12% divided by 4. Remember it's quarterly, so we have to divide by 4. Multiply by 4.5 multiply by 4. Alright, and then we have to subtract the withdrawal which was made together with its interest, 12%. 12% divided by 4 to the exponent of 2.75 multiplied by 4, which that gives us, after 7 years, this person will have 28,767.75 in the account, 75 cents in the account. Alright, I hope you guys understood this question, that when we make a withdrawal, we take out the withdrawal together with its interest, so that we do not disturb the 16,275 which was an original investment which was made. Alright guys, I hope you understood this lesson, and if you didn't, please just drop a comment and then we'll have a follow-up on it. Also, don't forget to subscribe to Maths XYZ on YouTube so that you will be able to get notification when we upload videos. Thank you.